Hello, this is Mr. Henry, and welcome to lesson 5.6. We have a major change of topic, sort of. The previous lessons have been talking about linear functions. Now we're talking this lesson about volume. These are examples of non-linear functions, although we're not going to graph them. It's just, that's the relationship between what we have been doing and what we're doing now. We've been looking at linear functions. These are all examples of non-linear functions. See, this question says, how do I apply formulas to find the volume of cylinders, cones, and spheres? So we have a Collins type 1, got 2 minutes. It says, list 10 examples of cylinders, cones, or spheres in real life. Go ahead, pause the video, do it on your own. When you're ready to continue, hit play, and we'll go through it together. Okay, so, you could probably come up with 10 examples maybe of each of these. Maybe not the cone. But, cylinders. You've got like a tennis ball. E-N-N-I-S, ball. You can do like a basketball. You can do the earth. Whoa, what am I doing? These aren't cylinders. Spheres. You can do the sun. You can do what's something else that's in the shape of a sphere. That's not just a ball or a planet. I don't know. I'll think of something. Cones. You've got like an ice cream cone. You got like an orange traffic cone. You've got a party hat. Cylinders. Well, you've got a can of soup. You've got a soda can. You've got, what else? A trash can. You could have a roll of paper towels. Looking around my room here, what else I got? Got a cup. There's a fire extinguisher behind me. There's a whole bunch here, and there's obviously more examples of spheres and cones and cylinders out there in the wild. So the lesson today is going to be about finding the volumes of these things. So you might be going, well, what the heck is volume? Volume is the amount of space a 3D object occupies. The amount of space inside, the amount of stuff you could put inside that thing, that object. Okay. Radius is, when you're talking about a circle, the distance from the center of a circle to the outside. So radius, if you have a circle, goes from the center of the circle to the outside. That is a radius. And a diameter is the distance from one point of a circle through the center to the other side. So if you have your circle, a diameter goes through the center and touches both points. Basically, it cuts the circle exactly in half. So a diameter cuts the circle in half. It is 2 radiuses. If you have a radius here and a radius there, that makes 1 diameter, as long as the radiuses are in a straight line. So one radius would cut from the center to the outside, the other from the center to the other outside. All together, that is the diameter. Okay. In the notes packet, I included the 8th grade formula sheet. This is the newest version, the 2014 formula sheet. If you've never seen this before, it is quite different than the old formula sheet. The old formula sheet had perimeter and area of things like rectangles and triangles and rhombuses and all that kind of stuff, circles, circumference. It had conversions from like feet to inches, miles, gallons, quarts, pounds, tons. It had changing from Celsius to Fahrenheit. It had Pythagorean theorem. It had a whole bunch of stuff. They've really reduced the amount of stuff on here. So it's broken down a couple categories. You've got your exponential properties. This was back in Module 1. We've got our algebraic equations, which we're still sort of using. This was in Module 5 and Module 4. This is Mod 1. We've got our Pythagorean theorem, which was back in Module 2. And then we have this volume stuff, which is in Module 5. Okay, so these three are the ones we're talking about today. We're talking about the cone, the cylinder, and the sphere. So it says here, the disk below has a volume of 2,200 centimeters cubed. What is the approximate height of the disk? Now, one thing you're going to want to do in every single problem is you're going to want to look at the formula sheet and you're going to write down the appropriate formula for the shape that you have. So this problem, they're giving us a cylinder. So we're going to look at the formula sheet, find the formula for cylinder, and we're going to write that down. V equals pi r squared h. V equals pi r squared h. Once you have your formula, so step 1, write formula. Step 2, substitute. So now you're going to take the information they give you in the problem. You're going to plug it into your formula. In the end, if you do this properly, you should only have one variable left over. If you ever have more than one variable, you need to plug some more stuff in because you cannot solve an equation with two variables. So let's see. The disk below has a volume of 220. So instead of volumes of the V, we put 2200. Pi. Well, you could leave the pi symbol or, personally me, 3.14. Okay. Let's see. Radius squared. What is the radius of this thing? Do we know? Yes. The radius is 15. Height. What is the height of this thing? Do we know? Doesn't say here or there. And the question is, what is the height? Which means we don't know that thing. Step 3. Solve. Now you find what h is. You do the math. So we're going to simplify as much as we can. So I'm going to take 15 squared. Calculator. It's 225. 15 times 15 is 225. So 3.14 times by 225. H is 2200. Order of operations. So we did exponents first. Now we're going to multiply. So take that times by 3.14 equals 706.5. H equals 2200. Okay, we've simplified. Now we're getting the variable by itself. So we're going to divide both sides by 706.5. And those cancel out, and we get H equals, clear, 2200 divided by 706.5 equals 3.11. So what is the approximate height of the disk? Well, we could say approximately 3.1 centimeters. So if that's 15, this height is approximately 3.1 centimeters. These three steps, will be the same in every single problem we're going to do. I'm always going to write down the formula first. I'm always going to substitute next, and then I'm going to solve. I'm never going to skip step 1. I'm never going to skip step 2. You shouldn't either. That's how you make sure you get your problems correct every time. The students that I see that commonly miss these problems is because they don't do step 1, and they just go right into step 2, and a lot of times they get their formula wrong because they didn't bother to check to make sure it was right. They didn't write it down. So make sure you do it in this order, all right? Letter B. Bill got an ice cream cone and wants to fill it with ice cream and have 1 scoop on top. If the cone is 6 inches tall and the opening has a diameter of 3 inches, what is the volume of ice cream inside the cone? This problem is for you to try. So use those same steps. Go back to the formula sheet, write down the formula. Substitute the values that says in the problem into your formula. Solve. Go ahead, pause the video right now. When you're ready to continue, hit play, and we'll go through it together. Alright, so let's see. It says this has a height of 6 inches. It has a diameter, which goes the whole way across, of 3 inches. Our formula for a cone is V equals 1/3 pi r squared h. V equals 1/3 pi r squared h. Double check it. Yep. All right. So now we're going to plug in what we know. Do we know the volume? No. The question is, what is the volume? So that's going to stay V. 1/3 is 1/3. Pi is pi. Radius. Let's see. Well, it gives me a diameter here of 3 inches. A radius is half of that. So if the diameter is 3, the radius would be 1.5 squared. See, radius squared. H, the height. Let's see, the height, it says, is 6. Oh, the other thing I'm always going to do, I'm always going to draw a picture and label my picture. If I don't have it drawn and labeled, you see how I labeled the 6 inches and 3 inches, you should do that too. I was just thinking in my head, a place the students would mess up is they would just look at the problem and go, okay, 6 inches, yeah, that goes in there, and 3 inches, yeah, that goes in there, and they're not paying attention and realizing that this 3 inches is a diameter, not the radius. And because the 3 inches is a diameter, the radius is half of that, and so we had to use the number 1.5 for radius, not 3. I predict there'll be a bunch of students who make that mistake. So by drawing and labeling your picture, you're lessening the chance of making mistakes. Okay? So step 1, formula. Step 2, substitute. Step 1.5, draw and label your pictures. Alright, step 3, solve. Well, this one's pretty easy. Now, it's ugly, but it's easy. You're just going to take this stuff, if you multiply it all together, that's going to give you your volume. So, order of operations. Exponents first. So 1/3 times by 3.14 times by whatever 1.5 squared is. Well, Mr. Calculator says 1.5 times 1.5 equals 2.25. Okay? We're just multiplying everything together now. So let's do this. 1/3, which is 0.3 repeated, times by 3.14 equals, this calculator is stupid, times by 3.14, better, times by 2.25, boom, times by 6, boom. Answer is 14.13, was like 0.0001, whatever. So roughly 14.13 inches cubed. volume is cubed. The label is inches cubed because volume is a three-dimensional measurement. So like if you're measuring the length of something, that'd be like in inches. If you're measuring the area of something, like a rectangle, that's inches squared because this is a two-dimensional shape. It has a length and a width. This just has a length. When you're measuring volume of like a cube, I know we're doing a cone here, but in general, if you're measuring volume, it'd be inches cubed because you have a length and a width and a height. So there's three dimensions, so your unit is inches cubed. 2 dimensions, squared. 1 dimension, inches to the first power. Okay? So the volume of this cone, or the volume of the ice cream inside of the cone, is 14.13 inches cubed. Write formula, label picture, substitute, solve. Letter C. Doug has a bucket that is 12 inches tall and has a radius of 6 inches filled completely with water. Now, I look down and I see it's already labeled 12 inches tall, 6-inch radius. Awesome. Doug pushes a basketball with a diameter of 10 inches completely into the water, overflowing the water in the bucket. How much water is left in the bucket? So it doesn't have labeled that this basketball has a diameter of 10 inches. So I'm going to label that my picture. So let's see. What are we trying to measure? We are measuring how much water is left in the bucket. What shape would that water be in? Well, it would be the shape of the bucket. Water is the shape of whatever it fills. If you put water in a cone, water's in the shape of a cone. If you put water inside of a cube, the water's in the shape of the cube. Since the water's inside this bucket, it's the shape of a cylinder. So we need to find the volume of our cylinder. V equals pi r squared h. And this is the volume of the cylinder. Okay. Now, after you push the water in here, some water is going to overflow. It's going to spill out over the sides. The amount of water that would overflow would be the volume of the sphere. So if we figure out how much space the sphere takes up, the basketball here, that would be the amount of water that was pushed out of the bucket. So our final problem is eventually going to be, we're going to take the volume of the cylinder and subtract the volume of the ball. Let's not use ball, let's use sphere. Use our proper language here. pH. And that will be the amount of water left in the bucket. Okay, so I'm going to rearrange a little bit here because this is my overall goal. If I can do this, this is the answer to the question. Now, that also means, do I know, just by looking at the picture, does it tell me anywhere the volume of the cylinder? No. We're going to find that out. Does it say anywhere in the problem the volume of the sphere? No. It tells us the ball has a diameter of 10 inches. Doesn't say what the volume is, so we're going to have to find that out. So once we find out the volume of the cylinder and the volume of the sphere, if we subtract them, that will be the answer to the question. So let's get to it. Step 1, write down the formula. Step 2, substitute. We don't know the volume of the cylinder. Let's stick with red for now. Pi is 3.14. We know, let's see, radius. Do we know the radius of the cylinder? We do. It's 6 inches. Squared. Do we know the height of the cylinder? We do. It's 12. Okay, so that makes finding the volume of this cylinder very easy. So we have everything we need. We just plug it in. So 3.14 times by 6 squared is 36 times 12. Mr. Calculator says 3.14 times by 36 equals times by 12 equals, I didn't actually look at the number, 1,356.48. 1,356.48. Double check it. Yes. All right. So this is the volume of the cylinder. Okay? Now let's find the volume of the sphere. I don't know that formula yet. We haven't seen that one yet. V equals 4/3 pi r cubed. Okay? V equals 4/3 pi r cubed. All right, so let's plug it in. Do we know the volume? No. 4/3. Well, we can leave them as 4/3. Eventually, I'm probably going to change that to a decimal. Pi is 3.14. Radius. Well, the problem gives me a diameter. It says the diameter is 10 inches. So radius is half of that. A radius is half of a circle. So if the diameter is 10, the radius is 5 and cubed. Write down the formula. Substitute. Solve. Now if we do this math, we get ourselves an answer. So let's see. 5 cubed. Actually, I can do that one. That's 125. 4/3 times by 3.14 times by 125 equals. All right. Now, to do 4/3, I'm just going to take 4 divided by 3 times by 3.14 times by 125, 523.3 repeated. All right, so we have the volume of the cylinder. That's how much water was in the cylinder at the very beginning of the problem. The guy pushes this basketball into the bucket, spilling out this much water. That's how much space the basketball takes up. So the amount of water left in the bucket would be the 1,356.48 minus the 523.33, giving us, let's see, 1,356.48 minus 523.33 is 833.15. And since we're talking about volume, it will be in inches cubed. So that was a DOK 2, depth of knowledge 2. That took some extra work. It wasn't just find the volume of the cylinder, where you just plug the numbers in. You had to find the volume of the cylinder, we had to find the volume of the sphere, and we had to subtract them to find the remaining amount of water that would be floating or that would be inside the bucket on the outside of this basketball. That's how much water is left in the bucket still right now, even though this basketball is completely pushed in there. All right. Letter D. At a party, Lexi went into a bouncy house in the shape of a half sphere, called a hemisphere. You see a little picture down below here. The bouncy house had a radius of 8 feet. What is the volume of the bouncy house? Go ahead, pause the video right now, and answer the question. When you're ready to continue, hit play, and we'll go through it together. All right, so since we're talking about a sphere, we're going to use that same sphere formula. Let's see if I remember it. It was, so for a sphere, H-E-R-E. I can't spell sphere for some reason. Try it again. S-P-H-E-R-E. The volume was 4/3 pi r cubed. Volume was 4/3 pi r cubed. Good, I got it right. See, I don't even remember these formulas very well. I have to look back at the formula sheet or my previous problems. You should as well. So let's see. What do they give us? They say the bouncy house has a radius of 8 feet. All right, so we're trying to find the volume of this bouncy house. We don't know volume. 4/3 pi radius, which is 8. Label it 8 feet cubed. All right, so we have now our labels. We have everything plugged in, so we just multiply. Let's do that. So we take 4 divided by 3, which is 1.3 repeated. Oh, wait. I didn't do my exponents first. I don't know what 8 cubed is. 8 times 8 times 8 is 512. All right, let's do that first. 4/3, 3.14 times by 512. So you got to follow those order of operations. They're there for a reason. Now, 4 divided by 3 times by 3.14 times by 512 gives us, I didn't look at it again, 2,143.57. 2,143.57. All right. Now, if you're thinking you're done, no, you're close. So if this is what you got and this is where you stopped the problem before you watch me do it, go back, read the problem again, and see if you can find where this is not complete. If you are done and you did more than this, the reason why this is not the correct answer is it says this is a half of a sphere, a hemisphere. This formula is the formula for an entire sphere. So if we would, that's an ugly, but if you imagine this being a whole sphere, then this formula would work. But because it's only half of a sphere, we need to take half of that volume because we're talking about a half sphere. So if I just take this volume, divide by 2, that would be my final answer. 2143.57 divided by 2 equals, still have it here, nice, divide 2 equals 1071.78. So this is the volume of the hemisphere, while this blue would be the volume of the sphere as a whole. Okay? That's why this is the correct answer and this is not. I bet on a multiple choice test, they're going to include this as one of your choices, hoping that you don't divide by 2, hoping you don't take half of that volume of the sphere to get the hemisphere. Letter E. A softball has a radius of 3.8 inches, while a baseball has a diameter of 2.94 inches. How much bigger is the volume of a softball than a baseball? Okay, now this problem doesn't have any pictures drawn for us, so feel free to draw your own. I'm going to. So there's one. There's the other. I'm not drawing them to scale. I'm going to call this guy, I guess, the baseball. This guy the softball. Simply because I drew this one a little bit bigger. All right, so it says here, the softball has a radius of 3.8. The baseball has a diameter of 2.94. How much bigger is the volume of the softball than the baseball? Now, hopefully you know by now, anytime the question is asking how much bigger, how much smaller, how much faster, whatever, that's always going to be a subtraction. So if we're going to take the volume of the softball and subtract the volume of the baseball, we'll get our answer. That will be how much bigger. So in order to do that, we need to find the volume of the softball, the volume of the baseball, and subtract them. All right, so let's do that. So we've got spheres. V equals 4/3 pi r cubed. V equals 4/3 pi r cubed. That's the same formula we've used in the past two problems. I remember it now. If you don't remember it, look it up. There's no shame in going back to your formula sheet, going, okay, sphere, V equals 4/3 pi r cubed. V equals 4/3 pi r cubed. Step 1, write down the formula. Step 2, plug in what you know, substitute. Volume equals 4/3 times 3.14 times by the radius, and this one does give us a radius of 3.8 cubed. Let's just continue with this softball while we're doing it. All right, so I'm going to take 3.8 and cube it. 3.8 times by 3.8 equals, times by 3.8 equals 54.872. 54.872. And now I just multiply everything together, and that gives us, let's see, 4 divided by 3 to change the... Whoa, what did I do there? Why did I put that as 3/4? 4/3 to change the fraction into a decimal, times by 3.14, times by this 54.872 equals 229.73. 229.73, and is that inches? Yeah, inches cubed. So this is the volume of the softball. Baseball. So for the baseball, let's do green. I don't know if it's the same color green or not. I don't think it is, but it's good. Whatever. So green. So now we have volume equals 4/3 times 3.14 times by our radius cubed. Now, this is not a radius. This is a diameter. If you put 2.94 in here, you're going to get the wrong answer. You have to take half of this. So 2.94 divided by 2, that's how you take half of something, divide by 2, gives us a radius of 1.47. That 4 looks like a 9. 1.47. And then we're going to cube that. So volume equals 4/3 times 3.14 times by 1.47 cubed. All right, 1.47 times by 1.47 times by 1.47 gives us 3.1765. 3.1765. I'm trying to include a lot of decimals because the more decimals you add, the more accurate your answer is. It's not good to shortchange yourself early in the problem. You can estimate down to the end and cut off some decimals at the end with little repercussions, but at the beginning or the middle of the problem, you want to include as many decimal places as you can to keep the problem as accurate as possible. That's why if you try this problem on your own and you get a problem numbers that's slightly different from mine, That's probably why. If you don't have the exact same number of decimals I do, our answer is going to be off. And now I just multiply this out. So 4 divided by 3 is that, times by 3.14 is that, times by 3.1765 is 13.29. I just want to type that in one more time, just to make sure. Number seems a little small, but it could be right. Times by 3.14 times by 3.1765. Alrighty, it's the right answer. So this is the volume of the baseball. So we found the volume of the baseball, the volume of the softball. So in order to find the answer, the question was, how much bigger is the volume of the softball? We're going to plug our numbers into our little verbal model up here, which I'll just bring down here for us. If we plug these numbers in, we have our answer. So 229.73 minus, so softball minus baseball, 13.29 equals answer. That's easy. Clear. 229.73 minus 13.29 equals 216.44 inches cubed. So a softball is 216.44 inches cubed greater in volume than a baseball. Letter F. 3 friends are sharing a soda from a can. The dimensions of the soda can are shown below, and you see you don't have the blue, you have them here, so you can copy them on your paper now. So 4.8 inches and 2.5 inches. If the 3 friends each drank an equal portion of the soda, how much would each friend drink? So if each person drank the same amount of soda from the can, how much would each person drink? Go ahead and do the problem on your own. When you're ready to continue, hit play, and we'll go through it together. All right, so let's see here. Well, we've got a cylinder here. And so the volume formula for a cylinder is V equals, let me think, it is pi r squared h, right? Aha, pi r squared h. Pi r squared h. Okay, so formula. Step 2, substitute. We do not know the volume. We know what pi is. We don't know the radius, but we can find it. This tells us this can is 2.5 inches in this dimension, but that's a diameter. A radius would be this much. So how much is that? 2.5, the diameter, divided by 2 is 1.25 squared. And the height is 4.8 inches. All right, and we just go to town on this thing. So we're going to do the 1.25 squared first. So 1.25 times by 1.25 to give us this unit. So 1.5625. 1.5625 and 4.8 and 3.14. And now we just multiply everything together. 3.14 times by 1.5625, boom, times by 4.8, boom, gives us a volume of 23.55 inches cubed. Now again, if this is where you stopped and you said this is your final answer, you're not quite right. This is the volume of that soda can. Good job. This is not the volume that each friend drank. If 3 people are drinking out of this can and each person drinks the same amount, so one person would drink like that much, one person would drink that much, each person is drinking a third of the soda. So we need to take the volume of this can and divide it into 3 sections, divide by 3, to figure out how much soda each person drank. So we're literally going to do that. We're going to take the volume of the can, and if we divide by 3, because 3 people were drinking out of it, divide 3, 7.85, that is the volume of soda that each friend drank. So this person drank 7.85, that person 7.85, that person 7.85, giving us a total of the 23.55, the total volume of the can, of the cylinder. So that's the volume of the can. This is the volume of the soda that each friend drank. Letter G. Crystal was told by her mom she could get 1 scoop of candy. There are 2 scoops, and both scoops are in the shape like, there are 2 scoops, and both scoops are shaped like a cone. Given the dimensions below, which cone should Crystal use if she wants to get the greatest amount of candy? Okay, so we have 2 cones, scoop A and scoop B. They're both shaped like cones. So which scoop should Crystal use if she wants to get the greatest amount of candy? Well, we definitely need our volume formula for cone. So volume equals, I'm thinking it's 1/3 pi r squared. Formula sheet says 1/3 pi r squared h. See, this is why you look it up. I would have forgot my h, and I've been way wrong. So to find which scoop gives us the greatest volume of candy, the greatest amount of candy, if we find the volume of the one and then the volume of the other, that's all we have to do. We don't even have to subtract them. We don't have to do anything. We just have to see which one's bigger. So which one has the greater volume. So we're going to use this formula twice. Once here, once there. So let's do them one at a time. So volume equals 1/3 pi r squared h. And plug in what we know. We do not know the volume. That's 1/3. That's 3.14. The radius, this is a radius, is 15 squared. And the height is 15. B equals, I'm doing 15 squared. We've already done that today. I know the answer. That's 225. And if we multiply this all together, that would give us the volume. So 1 divided by 3, to change this into a decimal, times by 3.14. Whoopsie, that messed up. 1 divide 3 times 3.14. There we go. Times by 225 times by 15 is 3532.5. 3532.5. And that would be in centimeters cubed. So this is the volume of scoop A. See, volume of A is this. Volume of B. Volume of B is 1/3 pi r squared h. Let's see. 1/3 times 3.14 times by the radius, and the radius is, I don't know. We have a diameter from one edge of the ice cream cone to the other. That's diameter the whole way across the circle. So the radius would be half of this. So half of 15, what was that, 7.5? 6.5? 15, yeah, 7.5 divided by 2, 7.5 squared. And then the height is 30. So let's see. Well, we got to do that 7.5 squared first. We've got to do these exponents here. So we're going to exponent this. So 7.5 times by 7.5 is, what's that, 56.25. 56.25 and 30 there, and 1/3 times 3.14 there, volume there. All right, so we've squared. We did the exponents first, and now we multiply straight across. Order of operations says, so 1 divided by 3 equals, to change the volume 1/3 into a decimal, times by 3.14 times by 56.25. Come on. 25. There we go. Equals. Times by 30 equals 1766.25. 1766.25. This is the volume of B, and that is in centimeters cubed as well. All right, so the question is, if Crystal wants to get the greatest amount of candy, which scoop should she use? Well, scoop A gives you a volume of this. Scoop B gives you a volume of this, which means scoop A is clearly the better choice. You get almost double the amount of candy using scoop A. So scoop A is by far the better choice than scoop B. Scoop A has the greater volume. There we go. And summary. So in your opinion, what is the most important thing to remember to do when solving problems involving volume? What do you think? You can probably guess what I'm going to say, but what do you think is the most important thing to do when you're solving problems involving volume? Go ahead, pause the video. You ready to continue? Hit play. We'll go through it together. All right. So, in my opinion, there are two extremely important things to do. The first of them is write down your formula. Write down your formula in every single problem. The more you write it, the more you see it, the more you hear it, the more you say it, the better you're going to remember it. So if you talk it out loud as you're writing it, even if you just whisper to yourself, if you don't want other people to hear you, volume equals 1/3 pi r squared h. Hey, that was one from the cone that we just did a second ago. So the more you hear it and say it and write it and everything else, the better you're going to remember it. The second most important thing is draw and label your picture. If you don't have a picture, draw one. Like here with the softball and baseball. We didn't have a picture, so you draw one. If you have a picture, make sure it has good labels. I mean, we had to find radius here. We had to find radius here. Well, we didn't know that, so we did the math, and, well, I guess I could have put it in there. The radius was then 7.5. Look at all the images, how much it helps us draw and label. Draw and label. Put the 8 feet in there for the radius. Okay? Those, in my opinion, are the two most important things you can do to solve problems. After that, it's just plugging the numbers in and doing the math, like multiplying. It's pretty easy once you can do those two things. All right, this has been lesson 5.6. Thank you for watching.